Hello, Pep Stars. Welcome. I know you would have been doing your practicing with your curriculum-based task items because you know that your exam is just in a few days, right? All right, so let me take this time to welcome you all to this session. This is our sixth lesson. And for those who have missed out on the ones that we have done previously, they are all there on the channel and they're all listed by lesson 1, 2, up to 5. And so you can always go back and do your practicing. All right, so now that we are here, there's some things that I want to remind you to do. Get your pencils, get your books, and get ready to do some practicing. Also, please note that this is a live stream on YouTube and this is where we will be interacting. So go ahead, get your materials, and let's start. All right, so first, I also want you guys to share which school you are joining in from so that I know where all my pep stars are checking in from. So go ahead in the chat, type the school that you're attending, and let's get started. So you know as usual that in curriculum-based tasks, it's really about the things that you have been exploring in class. And so these items will be surrounded or will be surrounding those topics that you have been doing in class. So let's get started. All right, so the first set of items we will be looking at our ratio type items. So when we talk about ratio, we talk about sharing, we talk about proportionality, we talk about all those kind of things. Ratio are also in fractions as well, and so on. And that is what we will be starting with. We won't be spending a lot of time on ratio, and we will tap into a few more important topics that we may see on this exam. All right, so the first question is, Jennifer is making friendship bracelets. She makes 4 with neon colors. For every 3, she makes with pastel colors. Now we're going to pick the diagram that models this ratio story, as well as we're going to try to answer this question. If Jennifer made 16 bracelets with neon colors, how many did she make with pastel colors? So go ahead. Think about friendship bracelets. We may have made some for our best friends or so on. So we're talking about just some bracelets that are unique and special for you and your friend. Now she makes with 4 neon colors. So for every 4 neon colors she has on a bracelet, there is also 3. She makes all 3 with pastel colors. So let's pick. We'll call the first one A. We'll call the second one B. And we will say which one, or we can call them diagram 1, diagram 2. It's up to you. All right, so go ahead, think about this and start exploring these items. In the meantime, I will take some time just to welcome the students I'm seeing here. I'm seeing students from Columbus Prep, Victoria Primary, Norwich, Bellas Gate, Santa Cruz Prep, Alvernia, Hopewell Boys Content, Nagoed Newstead, okay, Mineralites, Frankfield, all right, very good, Giovanni. St. Richard's, Victoria, Crescent Primary, Richmond Park, St. Aloysius, St. Francis Primary and Infant, Ensom City, Columbus Prep, St. Catherine Primary, Point Hill, Portsmouth, Grangeville, PGA Prep, Southborough, Manchonil, All Age, Marlymount, Wakefield Primary, Hope Valley, Trout Hall, Ascot Primary, Belfield, Brownstown, Bonnet Primary, St. Faith's, Hopewell Primary. Welcome to you all. Riverside, Columbus. Welcome to you all. So let's look at this one. Now, if she makes 4 neon bracelets with 4 neon colors, and that is 4 neon colors for every 3 pastel colors, which of these, diagram 1, diagram 2, represent it? So I just want to see in the chat diagram 1, diagram 2, A, B, and I will know exactly what you're saying. All right, so I see persons saying B. All right, let's check out B. I'm seeing lots of persons saying we're looking at diagram B or diagram 2. All right, so And I see Kevin Nee saying 3 to 4 and 4 to 3. But let's look at it. Now the question says she makes 4 with neon colors for every 3 with pastel colors. And the fact that she mentions, neon colors here, she talked about 4 neon colors. We're going to look for the diagram that is showing 4 neon colors or something that may be equivalent. We're also going to look for the diagram showing 3 pastel colors. So we have neon here, we have pastel here. And we have 1, 2, 3 for neon, 1, 2, 3, 4 for pastel. But it's really the other way around. So let's check the other diagram. We have 1, 2, 3, 4 for neon and 1, 2, 3 for pastel. And so definitely diagram B. Very good. So all we've said diagram B, that's brilliant. But let's look at the question now. It says if Jennifer made 16 bracelets with neon colors, how many did she make with pastel colors? How will we figure that out? So tell me, how many will she make with pastel colors? You can go ahead and represent this as a ratio in the chat. So go ahead, represent the answer as a ratio in the chat to show how many she made with pastel colors. All right. So she made 16 bracelets with neon colors. How many did she make with pastel colors? If we're following through with what we have started out here with this story that was presented to us. Go ahead and present your answer as a ratio. All right, so I'm seeing ratios coming in. I'm seeing 16 to 12 from Melita. I'm seeing 4 to 3 from Vashon. 16 to 12 from Jordan, and I'm seeing a lot of 16 to 12 and 4 to 3. I'm also seeing some 3 to 4, but we're looking here at neo to pastel. Now, remember we're talking about how many, we have 16 neon bracelets. So we are representing what this question is asking. How do you know that your answer is 16 to 12 or 16 to 9 or 16 to well, I'm seeing 6 and 12, 16 to 9, or 4 to 3, or 7 to 16. How do you know? All right, so Butterfly is saying she made 12 bracelets with pastel color 16 to 12, but how did we figure this out? All right, I see where Labrina is saying 4 to 3 is equal to 16 to 24, but let's look at that, Labrina. 4 to 3 means 4 neon to 3 pastels. That means at all times, if we're using this relationship, it would mean then that neon is always going to be more than pastel. So let's look at what you have there, Labrina. Let me see what you guys are sharing. All right, so Jordan Needham is saying that 4-3 is equivalent to 12 to 16-12. Melita says we divide 16 by 4, then multiply the answer by 3. Saskia says 16 to 12 or 4 to 3 if you simplify. Let me see what others are saying. Gregory says because you divide it by 4 and when you reduce it is 4 to 3. Vashon says if she made 16 bracelets, the sentence said 3 to 4 neon, which, okay, all right. So let's look at this. Let me start to represent what we have. So we know here that 4 neons to 3 pastel, that's the relationship that we're working with. If it is that she made 16 bracelets with neon colors, how many bracelet with pastel colors did she make? So if you look at the relationship here, you realize that so someone had mentioned that we divide 16 by 4, and that is what we can do here. So we divide the 16 by 4 to see how many parts of neon is there to pastel. If we have 4 neon to 3 pastel, it means then that in 16 we have 4 sets of this 4 neon, right? And if it is that for each of those sets, so 16 divided by 4 would give us 4 neon, And for each of these 4 neon, there are 3 pastel. And so we can multiply 4 by 3. If we multiply 4 by 3, that would give us how many pastel colors we have. So let's look back at this. We have 16 neon here. Oh, this should be a question mark. Let me just erase it. All right, so for every 4 neon, we have 16, we have 3 pastel. But in this case, Jennifer made 16 neon. It is telling us then that if it's 16 neon, every 4 out of the 16 that she made 3 pastel. So how many groups of 4 can we get from the 16? So we'll now have to divide our 16 by 4, which would give us a quotient of 4. And if we multiply that 4 by 3, it will tell us how many pastels she made for every 16 neon. So 4 times 3 is 12. So we have gotten what we need for pastel colors. So therefore, our answer has to be 16 neon to 12 pastels. Very good. All right. So I am really proud of your interaction here so far. Let us continue. So our answer here is 12 pastel colors. All right, so here we go. All right, so let's go to the next question. It says, at the Sunday salon, most customers order their sundaes with whipped cream. Last weekend, for every 9 sundaes ordered with whipped cream, there are 2 sundaes ordered without whipped cream. So we're going to pick the diagram first that models the ratio of the story. Which of these diagrams model the ratio of the story? And if it is that we're representing if you're representing our ratio by saying the number of with to the number of without, we have to pay keen attention of what we're using, the number we're using to represent with whipped cream and without whipped cream. All right, so sometimes we flip around our ratio relationship, but really if it asks here about whipped cream, with whipped cream to without whipped cream, that's how I want you to represent your answer. All right, so persons are saying diagram 1. So let's look at that and let's see why it really could be diagram 1. I'm seeing everyone saying diagram 1, diagram A. All right, so let's go. So what's happening here? At Sunday salon, most customers ordered their sundaes with whipped cream. Last week, nine sundaes were ordered with whipped cream and 2 without. So 9 with, 2 without. So we're looking for the relationship that has more with whipped cream and less without, because 9 is more than 2. And based on the relationship shown here, whipped in the first diagram shows more than in without, which is the second part of the first diagram. And so yes, we can say that the representation is with the first diagram. But the question being asked is this: if 36 sundaes with whipped cream were ordered last weekend, how many sundaes were ordered without whipped cream? That's the question we want to answer. And I want your answer to come in a ratio relationship. If I get a ratio, if you represent your answer in a ratio, then of course I would get the answer for this question. So I want you to show your answer as a ratio. So here it says, if 36 sundaes with whipped cream were ordered last weekend, how many sundaes were ordered without whipped cream? Let's think about that. Let's talk about that. And while you're thinking about that and working out, let us look and talk about this diagram here. If this diagram is showing, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9 with whipped cream and 1, 2 without whipped cream, can we see the relationship between the with and the without? All right, so we know that this is represented. What is this? What would this ratio look like with to without whipped cream? Go ahead and show that in the chat, with and without whipped cream. How would that ratio look? What would that ratio be? With whipped cream to without whipped cream. I want us to start with that. So go ahead and tell me, what would that relationship look like? What would that ratio be? All right. So it says here that we have 9 sundaes. Thank you, Jay Sean Heron and um, Devani Price. So we've got 9 with whipped cream. Let's start with that. To 2 without whipped cream. It says that last weekend's 36 were ordered with whipped cream. So let's put it on this side. This side is representing with. And so we want to figure out how many then were ordered without whipped cream. All right. So if we just look at this here, we have to think about then, if for every 9 with whipped cream, there is 2 without. It means then that we need to see how many groups of 9 we can get from 36, correct? So we have to see how many groups of 9, equal groups of 9 we can get from 36, because we need to now figure out this relationship. And so in order to do that, we have to do what? To find out that how many groups, equal groups of 9 we can get from 36. What would we need to do? And what will our answer be? Go ahead, express that to me, because I can see that you all are really working this out. Nikayla Garik says divide 36 by 9, then multiply 2 by the quotient that you got. So here we are seeing, all right, I'm seeing persons doing their calculation. Okay, good. So I'm seeing persons saying 4. So if I divide 36 by 9, I can get 4 equal groups of 9. So here, if it is that we have 4 equal groups, for every 9 there are 2 Sundays. So if we have 4 equal groups, we'll now need to do what? When we have figured this out and we got 4 equal groups, what do we now need to do to get how many Sundays there are without whipped cream? So the 4 equal groups, that means 1 equal group will be equal to 2 Sundays, and so 2 equal groups will be equal to how many without Sundays? All right, and so then we will have 36 Sundays to how many Sundays? Need to see that relationship in the chat. Let me see the relationship in the chat now. All right, 36 to 4 times 2, which is 8. Very good. So the first thing we need to do here is that we need to see how many equal groups of 9 we can get from 36. So we can multiply each of those equal group by the number of Sundays we have without whipped cream, and that will give us the total. So the 36 divided by 9 is 4, and 4 times 2 is 8. And so we now know that there are 8 Sundays ordered without whipped cream. So I see you all have been sharing that. Very good so far. All right, and I'm seeing you have shared, many of you have shared your explanation, and that shows that if you get a question similar to this with different numbers, you will be able to respond to it. Very good. All right, so let's move on to our next question. All right, so the next question reads, Raymond sings in a choir called the Seville Songbirds. For every 5 modern songs they learn, the choir leader teaches them 3 classical songs. Pick the diagram that models the ratio in the story. So let's first select the diagram that shows what the story is talking about. Will we say diagram A? Will we say diagram B? So Raymond sings in a choir called the Seville Songbirds. For every 5 modern songs they learn, the choir leader teaches them 3 classical songs. So it's either diagram A or diagram B. Are they studying more modern than classical or more classical than modern? Now in this diagram here, the first diagram, diagram A, is showing 5 modern to 3 classical. And the second one, it is showing 3 modern to 5 classical. All right, and I see you all sharing that it is diagram A, and I totally agree with you. Brilliant, because there are 5 modern songs, 1, 2, 3, 4, 5, 3 classical, 1, 2, 3, and that is represented clearly there. Nice. So let's look at the question. If the choir has learned 9 classical songs, how many modern songs have they learned? Firstly, I'm going to write the relationship that we have already established, 5 modern songs to 3 classical songs. So here, if the choir learned 9 classical songs, how many modern? So we're going to put our question mark on this side for modern and the 9 classical songs on the other side. All right, so how many modern songs have they learned? Will they learn more modern or less modern songs? Based on the relationship here, are we supposed to expect to see more modern songs than classical songs? Because however you write your relationship, the ratio that you're going to share here, you must write it with that relationship. Modern songs to classical songs. So will we see more modern songs than classical songs? And if so, tell me. How many more modern than classical? Tell me how many modern, how many classical. Represent that in the chat in a ratio for me, please. All right, so I'm seeing some ratios coming in. And I see Labrina explaining how she worked this out. So let me say what Labrina wants us to hear here now. So she says we have 5 to 3, and then we have exclamation question mark because we are trying to figure out how many modern there are to 9 classical. And so in doing that now, we're going to divide 9 by 3. All right, and then we multiply that 3 by this. Let me see. Divide 9 by 3 and we get 3. We multiply 3 times 3, which is this 9, and we multiply 3 times 5, which is this. Well, she's saying this is 15. Do we agree with what she's explaining here? Is Labrina on point? Michaela says it would be set out as 5 to 3 and they learned 9 classical. So 9 divided by 3 is 3, and you would multiply 5 times 3 to get 15. So that means there will be 15 modern. Let me know if you understand what they're saying and if you agree with them. All right, so while you share, okay, I see that you're agreeing with them. Great, awesome, brilliant. So let's look at it right here. We have 5 to 3, that is already established, 5 modern to 3 classical music or classical songs. So we need to see how many modern there are to 9. And of course, as she said, we need to see how many equal groups of 3 we can get from the 9, which is 3. So we divided 9 by 3, and the quotient that we have received means that we're going to see then, okay, we have 3, so that means we're going to multiply 3 by 5 to give us 15. So we'll have 15 to 9 classical songs, making sure that modern songs is more than classical. That is the story that we were presented with. So if you say 15 to 9, you are very much correct, and therefore how many modern songs have they learned? 15 modern songs. Nice. Brilliant. I see you guys rolling with me and I'm really proud of that. Lovely. Let's go to our next ratio question. So this is our last ratio question and we're just going to go on to a different concept. All right. So here it says, Carrie makes headbands as gifts for her friends. In the past year, she made 5 printed headbands for every 4 solid colored headbands. We're going to pick the diagram that models the ratio in the story. So Carrie makes headbands as gifts, and last year she made 5 printed for every 4 solid colors. Which of these is representing what she's saying? 5 printed for every 4 solid colors. All right, and I'm seeing everyone saying diagram A. It seems as if it's always diagram A. All right, and then so let's see if it is that we are on point to say 5 printed. Let's look at printed. We have 1, 2, 3, 4, 5, and 4 solid, 1, 2, 3, 4. And of course, once it's also representing, we have to make sure we look for the ones representing more printed than solids so that we can check to see if the relationship is represented correctly. Very good. All right, so now that we know that, let's go to the question. It says if Carrie made 20 solid colored headbands in the past year, how many headbands has she made in all? So let's go ahead and represent our original ratio. Printed to colored. All right, to solid colored. So we've got 5 printed to 4 solid colored. If Carrie made 20 solid colored headbands in the past, how many headbands has she made in all? Now, you're going to represent this first as a ratio, and then you're going to answer the question that is asked. All right. So I see person sharing ratio 25 to 20. Okay. I'm seeing Vashon says you multiply 5 times 4 and get 20, then multiply 4 times 4 and get 16. Therefore, the answer is 20 to 16. All right, let me hear what others are saying. Remember, the question is asking us how many headbands has she made in all. All right, so while you're going to give me how many she made in all, I also want you to represent the ratio in the chat. So here we've got 5 to 4. 5 printed to 4 solid. And if she made 20 solid, so I'm going to just put a little question mark here. We need to see how many printed. I keep writing that. So let me put a question mark here. To 20 solid. All right. So how do we figure out how many printed she would have made if she made 20 solid? Nicola says 25 to 20. So we have 20 divided by 4. So we divide 20 by 4. Nicola Harrison is saying, and that's 5. And then we multiply that 5 by this 5 here to get how many printed she made. So 20 divided by 4 is 4. 4 multiplied by 5. 24 into 20. 20 divided by 4 is 5, sorry. And 5 divided by 5 is 25. Let me hear what Freezer please thinks. She says that, okay, to get our answer, we're going to divide the 20 by 4 and we're going to get 5. All right. And then we multiply, all right, the 5 by 5. So you all are on the same point. So here we multiply 5 times 5. So we have 25 printed to 20 solid. Let me just backtrack a little. All right, so we can catch up those who have not yet gotten this yet. So we have the relationship 5 printed for every 4 solid. All right, so 5 printed headband. Carrie makes 5 printed headband for every 4 solid headbands. But it says now, if she made 20 solid headbands last year, how many headbands has she made in all? But in order to know how much she made in all, we have to know how many printed and we have to know how many solids. So that is what we're first trying to figure out. So here we know the relationship 5 printed to 4 solid, but we need to figure out how many printed she made if she made 20 solid. So we have to keep in mind that we ensure we represent the relationship in a way that is, we can follow it. It's homogeneous. It's the same throughout. So we have the printed on the same side, the solid on the same side. If we've got 20 solid colors, how many printed will we have? In order to figure that out, we have to see how many equal groups of 4 we can get from 20. So 20 divided by 4 is 5. The 5 that we get now, we need to know, okay, so she has 5 sets of 4. We need to multiply that 5 by the 5 printed headband she has. So she makes based on this relationship to get 25 printed headbands. So for every 25 printed headbands she makes, she would have made 20 solid as well. So in all, we need to do what? We need to sum them up. We need to find the total. We need to add these. And so how many? I need to see the answers coming in now for the total headbands that Carrie made last year. That is what we need to see. All right. So I see persons 65, Crystal Life, and I see persons sharing that it's 45. I see Anagram saying 45, Jay Sean, Dolores Curry, and I see persons coming in with 45. So 25 plus 20. That's pretty easy math, right? But I'm going to work it here anyway. 25 plus 20. So 0 plus 5 is 5. And 2 plus 2 is 4. So 45 headbands in all. All right. So she made 45 headbands in all. Very good, guys. Very good. Awesome. Now let's move on to another aspect. We're going to look at estimation because I believe that estimation is very good. Being able to estimate things is very good, especially when you're thinking about math. So let's look at our first estimation item. Miss Shepherd is a teacher with 28 students. Every school day, Miss Shepherd prints out 2 pages of worksheet for each of them. There are 81 school days left in this school year. So Miss Shepherd works out that she will need to print a total of 137 pages in this time. Does that sound about right? Now, we have 3 options here. Yes, no, it is much too high. No, it is much too low. So I want you to share. We can call these A, B, and C. All right, no problem. We can call these A, B, and C so it's easy for us to represent, or definitely you can go ahead and you can just write, what the options are saying. So Miss Shepherd, she has 28 students, but I want to see some answers coming in first. She has 28, so I'm just going to read and go through without the explanation, but I want to see the answers coming in. All right, so she has 28 students. Every day, she needs to print out 2 pages of worksheet for each of them. All right, there are 81 school days left in this school year. So Miss Shepherd works out that she will need to print a total of 137 pages in this time. Does that sound about right? Remember, we're estimating. So I see answers coming in for B and C. But guys, tell me, what do you mean? I see person saying A, B, C. Go ahead, guys. Tell me, why did you choose that for your answer? We're estimating now, so I want to see your explanations coming in. Why did you choose B? Why did you choose A? Why did you choose C? All right. Labrina says our answer is C because 81 times 2 is 162. So you think the answer is much too low. All right. All right. Okay then. All right. Let me hear what the others are thinking. 28 times 81, Crystal Life says 2,268, so that is too low. But why are we multiplying by those numbers? Why are you guys multiplying and adding those numbers as you are? Tell me. All right, so in order to figure out our answer, we need to know what the actual answer is, right? Or what it is about. Or, so let me look at what Vashon is saying. He says C is the answer because if she has 28 students and has 81 days left, she must multiply 28 times 81 to get the pages she needs. But remember now, it also says that 2 pages each day for each of them. All right. So Michaela says you would multiply 28 by 2 to get 56 because there are 38 students Okay, I think she means 28 students, and she prints 2 daily. Multiply 81 by 56 to get 4,536 papers. So she picks C. All right, and I like your explanation, Michaela. I'm just going to run along with that to see if we're really so definitely, she has 28 students. If she prints 2 pages of worksheet each student gets 2 pages daily. Let's see how many worksheets each student will be getting each day, or the class she needs to print for the class each day. So that means we have 28 multiplied by 2, because we need to see how many she's going to print each day. 28 multiplied by 2, what would that be? 28 times 2 is what, guys? Go ahead and help me with that in the chat. 2 times 8, 16. 2 times 2, 4, and 1, 5. So 56 daily. She needs 56 per day. So I'm going to just write this here. 56 per day. Now there are 81 days left. Remember, you know, she believes that she's going to need a total of 137 pages, but she is going to print 56 daily for her class, and there are 81 days left. So 81 multiplied by 46, because we need to see 81 multiplied by 56, so we need to see how many she will now need in all. Go ahead, do your calculation in the chat and tell me. 81 multiplied by 56. That will tell us how many she will need for the rest of the school year. All right, so go ahead, do your calculation and tell me. Do your calculation, and I want to see that in the chat. All right, so I see persons putting in 4,536, 4,532, 4,546. Go ahead, check your calculation, guys. And then I will go ahead and do my calculation as well. All right, so Shanieka Devashi is saying 4,536. Very well. Now, if it is that the actual number that she'll need is 4,536 pages, and she believes she'll need 137, yeah, it is really very much too low. So our correct answer is definitely the third option. C, as we can put it. No, it does not sound about right, because whatever she decided, 137, it is much too low. Very well. Very good, guys. All right. So now let's go to our next question. And this is lovely because we need to learn how to estimate. Very good. Our next question is this. Zoo tickets cost $19 for a child and $29 for an adult. Mrs. Carter, Mr. Carter, Mrs. Carter, and their kids estimate it will cost roughly $100 for the family of 4 to visit the zoo. Is that a good estimate? Yes? No, it is much too high. No, it is much too low. Tell me. So $19 for one child, $29 for one adult. How many people going? How many adults? How many kids? Go ahead and let's think about that. So Mrs. Carter is going, Mr. Carter is going, and their children are going. So, and they estimate that it will be roughly 100. Remember now, estimate is not exact. They say they estimate it will cost roughly $100 for the family. That family of 4 to visit the zoo. Is it a good estimate? Is it a good estimate? Yes. No, it's much too high. No, it's much too low. All right. All right. So I see answers coming in. So let's go ahead and I hope you're doing your calculations so that you can justify your answers. Okay, so I'm waiting to see some justification coming in the chat. All right. So Crystal Life is saying much too low. 19 plus 19 plus 29 plus 21 is 96. So $96 is the actual amount they need to spend Crystal Life. They estimate it's roughly $100. You're saying that their estimate is too low. All right. Let me see what the others are saying. I want to see what the others are saying. Now, if we're thinking about estimate, guys, we're thinking about estimate, it will not be exact. That's what that estimate is. I estimate that that person is 6 feet tall. I'm just saying. But the person is really maybe 6'1", 6 feet and 1 inch tall. Estimating. When we're estimating, it's almost like we are rounding up or rounding down. We're just rounding off. We don't have the exact figure, so we are rounding. So estimating is quite like rounding. Now, if it is that they estimate that it will cost about $100 for the four of them to visit the zoo, let's see if it's a good estimate. So $19 for one child, $19 for the next child. It's four of them. $29 for the adult, and it's two adults. 29 for Mr. Carter, 29 for Miss Carter. Now, let's look at it from this angle. We could first go ahead and we can add all four of these. That is one way to think of it. And whatever answer we get, we see if it's roughly $100. Or what we can do, because we're estimating, we're not going on any calculator, we may not be doing any any working out or anything. We can say $19 is about $20, don't it? So $20, $19 is about $20. The next $19 is about $20 too. The $29 is about $30. How we're estimating everything. It's an estimate. $29 again is about $30. And if we are able to estimate these things, it's quite easy for us to go and do our calculation, because we have basically rounded these numbers to a comfortable number so we can do our calculation in our heads. So if for two child it's about $20 for one, so that means for two child it's about $40, right? And if for one adult it's about $30 for one, it means then for two adults it's about $60, and $60 plus $40 is about $100. Now it says roughly, it says estimate. So if it is that we cannot think of it, so let us look at this. If we round it off, we get 100. This is one way. Before I go any further, let us just work out the actual amount. 9 plus 9 plus 9 plus 9 is what? That looks like 36. 3 tens, 4 tens, 5 tens, 7, 9 tens, 96. So the actual amount of money they'll spend is $96. Sometimes we go to the shop and we buy something or the supermarket and it's $96, and we probably just say, okay, keep the $4 change. We're rounding off. So estimate is a rough guess. It's a rough calculation. So definitely the actual amount is $96. But if we are guessing and if we are rounding and if we're estimating and we say $100, we are definitely on point. It's an estimate. So yes, it is a good estimate. It's not much too high. It's just $4 more than the amount that we need. And it's not much too low because the estimate is more than the actual amount. And so the correct answer for this is yes. It is a good estimate. Very well, guys. And I see that you all are really rolling with me and doing your calculation as well. Now, for an estimate, estimating and stuff like this, it doesn't really call for us to do deep calculation if we're estimating. That's why we're estimating. We're doing a rough guess, by using some other mathematical skills and coming up with a rough guess. Very good, guys. Let's move on to our next problem. Greg's youth group is collecting blankets to take to the animal shelter. There are 38 people in the group, and they each gave 2 blankets. They got an additional 29 by asking door to door. They set up boxes at school and got another 52. Greg works out that they have collected a total of 121 blankets. Does that sound about right? All right, so go ahead, do your calculation with the information presented here. So Greg Hughes Group is collecting blankets for the animal shelter. 38 people are in the group, and each of the 38 people gave 2 blankets. All right, think about this step by step here. Each gave 2 blankets. They got an additional 29 by asking door to door. They set up boxes at school and they got some more. They got 52 more. And Greg now work it out and said that they collect about 121 blankets. Does that sound just about right? Yes? No, it is much too high. No, it is much too low. What do you think? What do you think? What would your answer be? All right. I see person saying B. No, it's much too high. I see Jnor saying it's much too low. And Dolores saying the same thing. Oh, Dolores saying D. We don't have D. Okay. So Nikela is saying it is much too low. Now, the correct answer here, Nikela, is yes, no, it is much too high, or no, it is much too low. One of these is the correct answer. So if you're going to say that the correct answer is 156, I think you mean to say that the exact amount collected is 156 if you have done some calculation. Let's think about it. So persons are saying no, it's much too low. Persons are saying it's much too high. Let's first go ahead then to figure this out, and let's think about the actual amount to see if it is close to what our answer, the correct answer, should be. So if it is that there are 38 people in the group and each give 2 blankets, let us just do a estimate that. So if it's 38 and they give about 2 blankets, we're estimating what, 40 people, so we can say we estimate about 80 blankets right there. We're estimating, this is not calling for no calculation, we're estimating. So if it is that the people give about 80 blankets, we know it's a little less because we rounded up, so it's a comfortable number to work out. All right, now they gave an additional 29, that's about 30, right? So 80 and 30 would be about 110 blankets, correct? And then they collect about a 52. So we can say, all right, 110 blankets here and about 52, we can say about 50 that, right? Because we have rounded up some already in our calculation. So if we round down 52 to 50, that's a lovely number to calculate, to add to 110. So that means 110, and we're estimating here, nothing will be exact, plus the 50, because we're just rounding off, would be about 160 blankets. Now, of course, some of you would have done the calculation, but we're estimating here. So if we estimate, if Greg said that they collect about 121, but based on our rough calculation, we got 160. Is it much too high? Is it just about right? Or is it much too low? Now, some of you did your calculation, and I did it too. I calculated 38 plus 38 plus 29 plus 52, and I got 156. Now, 156 is just 4 less than 160. So it's a nice 156 and 160 is in the same range. Now, say we have 121, but yet still, we rough calculate it in our mind and we got 160. It's much too high. So our answer would have to be no, it's much too high, because if you find the difference of 121 plus this estimate that we have, or this rough calculation that we have, it means therefore that we would have about 39 more blankets than the actual amount. Or let us think about it, we'll have 35 more than the actual amount. whatever calculation there. But 121 is very low compared to 160. 160 or 156 is a lot higher than 121. It's not higher by 5, or it's a lot higher by 30 something. And so the estimate that he has here is much too high, because 160 is higher than 121 and 156 is higher than 121. All right, so I hope we all understand this, and we're going to now move on to our next question. Very good, guys. Let us look at this. Now we're going to go to part C, where we're going to do some comparing fractions. All right, so we're going to look at comparing fractions. All right, so our first question here is this. Mr. Jones finished correcting half of the week's homework assignments, and Miss Smith finished correcting 5/8 of that week's homework assignments. Which teacher corrected a greater fraction for her homework assignments, Mr. Jones or Miss Smith? All right, Mr. Jones or Miss Smith. So Mr. Jones corrected half of the homework assignments, and Miss Smith corrected 5/8. Who corrected more? Who corrected a greater fraction of? All right, so here we have Mr. Jones a half. We have Miss Smith's 5/8. What do we need to consider when we're answering this question? What's a very important point that we must acknowledge before we can answer this question? Because as I can see, half, 5/8, they just look like some fractions, and I have to do something, whether I'm going to do it mentally or I'm going to do it on paper. But there is something that I must recognize between these two fractions here. So I see answers coming in, but why do you choose that answer? Why is that answer you're correct for you? All right, so I see Labrina Markland saying half is equivalent to 4/8, and 5/8, which is the same as 5/8, is, so the answer is Miss Smith. I'm seeing Jenor saying 4/8 is equal to 1 to a half, and 5/8 is larger, so Miss Smith is the correct answer. Now I like to see those explanations. So we first have to ensure that we make equivalent fractions, so we have the same equal parts, for each fraction. So in order to ensure that we're representing half using parts we have 8 equal parts, and we're representing half with that, we have to see what equivalent fraction we can get for a half with the denominator 8 or with 8 equal parts. So a half, in order to do that, we can always do some cross multiplication, where we're going to say, okay, 2 into 8, or 8 divided by 2 is 4. So 4 ones 4. So now we've got 4/8 for this one. We can think about it like that. Or of course, we can go ahead and we can draw a hole, and we can have 8 parts in this hole. And then with the 8 parts, we shade half of it, and how many would be shaded, and we can use that to represent our fraction as well. We can use either way. By the way, these are all meant to be equal. So 1/8, 2/8, 3/8, 4/8, and we have 1, 2, 3, 4/8 not shaded, so equivalent is 4/8. So 4/8 and 5/8, which one is greater? Surely 4/8 is less than 5/8, and so Miss Smith, who completed 5/8, would have completed a greater fraction of the homework. All right, and I see a lot of you guys explaining similarly here in the chat. Really proud. Nice. So the correct answer is Miss Smith. Brilliant. Before I go, I'm just going to read what Michaela has explained. Michaela says you can use LCM to solve this. So LCM of 8 and 2 is 8. So 8 divided by 2 is 4, and 4 times 1 is 4 eighths. And 8 is divided by 1 is 8. 8 divided by 8 is 1. So 5 times 1 is 5 8. So the answer is Miss Smith. All right, lovely, brilliant. All right. So remember that if it is that during our explanation you have not gotten a full understanding, feel free to always go back and pause and try to listen to some explanation and even try to work it out on your own so you can get a greater understanding. Let's move to our next question. A supermarket found that 9/10 of customers bought vegetables and 1/3 of customers bought fruits. Which purchase was made by a greater fraction of customers? Vegetables or fruit? Go ahead and share your answer in the chat. Vegetables or fruit? All right. So the supermarket realized that 9/10 of customers bought vegetables. I'm going to go ahead and I'm going to represent that. So 9/10 bought vegetables and 1/3 bought fruits. Michaela had said that it's good to think of LCM because we first need to figure out equivalence with these fractions. We need to make these fractions equivalent. So how can we do that? In order to make these fractions equivalent, we must think of what equal number of parts we can put for each of them that we can get 9/10 from one and a third from the other part. So let's go ahead, not from the other part, but we would have made a whole, change this into a whole with the same number of equal parts as we would use for the same 1/3. And once we're able to get 9/10 from this amount of equal parts here and 1/3 from the amount, then we will be able to discover what the equivalent fractions are for these. So in order to think about that, we will have to now think about what is the lowest common multiple so we can think about the equivalent fractions. Of course, we can go ahead and we can draw our, our fraction bars and do our, equal sharing and stuff like that. But since we are in grade 6 and we should be, we should know about some of these algorithms, we're going to look at LCM. So let me go here and I'm going to think of LCM. So what do you think this LCM would be? What's the lowest number that 10 can go into without leaving a remainder, and 3 can also go into that number without leaving a remainder? Now, the first thing you need to do in regards to that is we need to list the multiples of these numbers. So let's list the multiples of 10. The multiples of 10 would be 10, 20, 30, 40. And I'm just going to stop there. All right, so we're listing the multiples of 10. I'm just going to stop there. We can always go further if we need to. And then now I'm going to list the multiples of 3. Now I'm going to keep listing the multiples of 3 until I come up with any of these numbers that are here. So let's go ahead and list the multiples of 3. Now, yes, I see you guys would have come up with a number, but let's go ahead and we need to think about this because at the end of the day, not everyone understands how we can come up with the numbers. So let's go ahead and list those multiples of 3. I need to see you helping me out in the chat. So we have our first 3, 6, 9, and it's almost like we're using our times table, guys. We're multiplying by 3 each time, and we're going up by consecutive numbers. So we have 3, we have 6, we have 9, we have 12, we have 15. We have 18. I see Tamara and Nikayla helping me out real quick here. We have 21. We've got 24. And while we are going ahead, we have not come up on any number, any multiple that is already there for 10. So let's keep going. We have 27. We have 30. And 30 is one of the multiples of 10. And so we can stop there because now we would have come up with the lowest common multiple for both these numbers. All right, so we see 30 in this set, and 30 is the smallest common number in common multiple in this set as well. And so our LCM, which is going to be our common denominator, will be 30. That means we're going to divide each whole into 30 equal parts. All right, so now to find LCM, we now need to say 10 into 30, or 30 divided by 10, and that would be 30 divided by 10 would be 3 times 9, that would be 27. So 27/30, or 27 out of 30, represents vegetables. All right, let's look at a third. 3 into 30, or 30 divided by 3, that's 10. And 10 times 1 is 10. So we would have made equivalent fractions here. And so it's easy for us to compare these fractions. Now it asks which purchase was made by a greater fraction of customers. 9/10 is for vegetables, 1/3 is for fruit, and so since 27 out of 30 is greater than 10 out of 30, it means then that vegetables was the greater purchase. The greater purchase was vegetable. All right. So I saw that you guys would have explained that earlier, but we also needed to do our explanation. Very good, guys. Do you agree it's vegetables? For the persons who may have said fruit, I'm not sure the persons who have, but do you now see why vegetables is the correct answer? Go ahead in the chat and let me know if you agree that the answer is vegetables. All right. All right. Brilliant. Let's look at this one. This one says, last week Shane's swimwear sold 3/5 of his bathing suits in stock. Maria's son wear sold 3/7 of his bathing suit in stock. Which store sold a greater fraction of the bathing suits in stock? So we're first going to represent that. So Shane swimwear 3/5 and Maria's sunwear 3/7. Now, I mean, this should be quite simple for each of you. If you look at it, you should be able, based on the different rules when comparing fraction, if you look at this, you should be able to figure this out. So I'm going to allow you guys to share the answer. Is it Shane's swimwear who sold the greater fraction of bathing suits in stock, or is it Maria's sunwear? And I want you to tell me why in the chat. All right, why did you choose Shane, or why did you choose Maria's sunwear? Tell me why. There is a basic principle or rule when you're comparing fractions that looks like this. So tell me, why did you choose whatever answer you chose for your correct answer? Why did you choose Shane, God bless Hewlett, and 65? Why did you choose Maria Nardia? Simone, why did you say Shane's? Kalian, why did you say Shane's? Go ahead. When you put your answer, tell me why. Shane's swimwear because. Maria's sunwear because. Go ahead and share your answer. Why did you choose that? All right, so, okay, so I see Crystal Life went ahead and said that 3/5 is the same as 21 out of 35, and 3/7 is 15 out of 35. So Shane's swimwear is greater. Okay. Now let us look at this. Let us look at this. I mean, let's look at this. I want to see the basic explanation when we're looking at fractions like this. Now I see Jay and Noor saying Maria because the larger the denominator, the smaller the fraction when dealing with like numerators. Now, the rule I want us to come up with is that sort of a rule when we're talking about whether like numerator or like denominator. But JNR, I want you to think about your explanation and see if it is really so. All right, in order to prove your explanation, you can also go ahead and you can draw up your bars to prove or if it's correct or not. JD says Shane swimwear because the denominator is smaller. When the denominator is smaller, the fraction is bigger. Nordia says Maria sunwear because the numerator is the same. So you have to look at the denominator to see which one is higher. All right. Ramona says Shane's because the LCM of both numbers is 35. So Ramona, you're doing a long workout there. But it's for questions like these, when we look, if we look and we see that the numerator is the same, because in this case, the numerator is 3 for both fractions, but the denominators are different. When the denominators are different, how do we know which fraction is greater? Now, I'm not going to answer that by just 2 words. I'm just going to go ahead and I am going to let us represent that here. So I'm going to have 2 same size rectangles. All right, and then I'm going to make 3/5 in one and 3/7 in one, because especially for the persons who are doing calculations, it does not require us to do calculation because it shows a basic principle, of fractions. All right, so let me go ahead and divide these equally into 7ths and into 5ths. All right, I'm trying my best to make this equal parts, but it's not really quite working out like that. So just bear with me because these are meant to be equal portions. But I'm not using a ruler, so some may look bigger than some. And it would be nice if you guys would have explored this as well, similarly in your book or something. 3, 4, okay. So these are turning out to be some big and some small. Let's see if we have 7 here. So we have 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5. All right, so these are expected to be the same sizes, not drawn to scale. Now I'm going to shade 3/5. All right, and I'm going to shade 3/7. And you know what? I am not comfortable with this drawing. So let me just go ahead and let me represent this using a different fraction, a different way. So let me go ahead. I'll stop share. And I'm going to go ahead and I'm going to express it here. All right, so I'm going to make 2 holes, and I'm going to make one with 5 to show 5ths, and I'm going to make one with 7 to show 7ths. Now these are the same sizes, same size holes, but divided into different amount of parts. So here we have 3/5, 1, 2, 3, and we have 3 sevens, 1, 2, 3. Now, the rule is that if we have two fractions, we have shaded the same number of equal parts. That means the numerators are the same, but the denominators are different. If the denominator is larger, it means that the parts has to be smaller. It's the same size whole, and we cut it up in more parts. That means each part is going to be smaller. It's like we're sharing a piece of, I don't know, say a bulla, and we're sharing the bulla, and we're sharing, it instead of sharing it for you and your four other friends, so 5 of you, you now have to share it for 7 of you now. Each of you are going to get a smaller portion. But if it is that the denominator is smaller, it means that you have less equal parts, and so the parts must be bigger. All right, so we need to think about that when we're comparing this. And so 3/5 is definitely going to be greater than 3/7. Now, let us think about it having the same denominator. I'm just doing another example here, just to concretize this before I move away from this. So I'm going to make 2 holes this time, and they're going to be the same size, the same sizes. Same sizes with the same number of parts. All right, but in one part we have shaded 1 2/5, and the other part we have shaded 1 2 3/5. Now we've got the same size hole, we have the same number of equal parts, but you realize that the smaller the denominator, the smaller the numerator, the smaller the fraction, or the smaller the amount of shaded parts, or the amount that you've taken out based on the context. But the larger the numerator, the greater the fraction, right? So we have to think about that, consider that, and so this will give us a good understanding of what we need to do. All right, let's go back to our question. I hope we understand that. For questions like that, we need not do calculations, because there are rules that help us to work with that straight away. So in this question now, which store sold a greater fraction of the bathing suits in stock? Go ahead in the chat, let me see your answer. If your answer is Shane's swimwear or Maria's sunwear, go ahead and share your final answer in the chat, and I hope that you all understood what I would have explained just now. All right, brilliant. All right, so yes, 3/5 must be greater than 3/7, and that was also shown in what we just did. So Shane's swimwear sold a greater fraction of bathing suits. Great. All right, nice. Let's move on to our next question. And you're doing so good so far, guys. Now we're going to look at surface area. Now, surface area has to do with the area of surfaces, but surface area is what we explore when talking about solids. So it means that we're talking about more than one surfaces, and we're finding like the area for solids. So what is the surface area for this solid? Now, before I even say anything of this, I want you guys to explain to me, how we can figure out the surface area for this. Tell me, if we're trying to find the surface area for this solid, what's the name of this solid, by the way? If we're trying to find the surface area of this solid, how would we do that? All right. All right, guys. So let's focus on what we're doing here, guys. So let's look at this solid. What's the name of this solid? Michaela says surface area is when you multiply the length by height by width. Are we sure? Are we sure that's really what the surface area is? When we're finding the area, okay, yes, it's a cuboid. Very good. When we're finding the area, we find what? So say, for example, we're looking at this face here that we're showing. This face here. How many faces does this cuboid have? And then we're looking at this face right here. What's the area of this face? We're looking at the area of this face here. We're looking at the area of this. What if we were supposed to open this solid and present it as a net? What would the surface area be? Those are some things we have to think about. So when we're finding surface area, we're just going to be looking at the area for all the different faces. And if we know the area for each face, if we put all of that together, we will come up with the surface area. So let's look at this first one together, but you guys can go ahead and calculate it. Let's look at this first one together. I see person saying 6, person saying 4, and so on. But let's look at this surface area here. So let's look at it. So this cuboid here has 6 faces. Very good. So I see you guys saying 6. Oh yeah, that's what you were answering to. So we have this face on this side, and we have another one on this side as well. So this face that we have here, we have the same size on the other side that we cannot see. For the one at the top, we have this same size face at the bottom that the solid is sitting on that we cannot see. For this one here at the front, we have the same size face at the back here that we cannot see. And so there are 6 faces. In order to find out the total surface area, the surface area basically, it's going to be the same thing, of this solid, is that we need to find the area of each face and then total that. So let's look at this face. We're going to call this face, I don't know, we can call it face number 1. And what would the area of this face here be? So this face here that I'm outlining, what would the area of this face be? Go ahead and tell me, what is the area of this face? So for the dimensions of this face, we have, here is 4 centimeter. It is shown. And from the base going up to the top is, based on this side, it shows that this part is 3 centimeters. All right. So what is the area of this face? Now, I don't want to see just a number. Thank you, Exo Kaylee. 12 squared centimeters. All right, so 4 multiplied by 3 give us 12 squared centimeters. I'm just going to write it here. And if we have this face at the other side, the same size face at the other side, it means that so far we have 2 12 square centimeter faces. Let's look at the top. What would the area of the top be? Let me just go ahead and outline this top part that we're talking about. What would the area of this top part be? So you can go ahead and we can call this top face. So you can say top face is equal to, and you write the calculation. This is front face, and this we can call this side face, and you tell me what the calculations are. So for the top face, what do you think the area of this will be? So we have, if right here is 4 centimeters, it means right here is also 4 centimeters. And if here is 1 centimeter, it means that right here is also 1 centimeter. So what would the area be of this top face? Thank you, Amelia. 4 squared centimeter. 4 times 1, like we're doing length times width. So this top face is 4 squared centimeter. Let me go ahead and try to write it very small so it holds. All right. So now we also have this side one, this side face here. If right here, let me outline this with a different color. All right, so we'll call this one the side face. And remember that for each of these faces, we have the opposite face for it being the same size. So this length, this dimension of the side face is 3 centimeters, we can see. And this part is 1 centimeter. So the area of this side face is what? The area of this side face is what? We have one dimension 3 centimeter, the other one is 1 centimeter. So if we're using the formula for area, length times width, we'll have 3 multiplied by 1, and we will now have 3 squared centimeters. All right, so 3 squared centimeters. But since it is that we have 2 of each of these faces, what will we need to do? You go ahead and work this out, and then you tell me what the surface area is going to be. I just want the final answer now. Okay, so we have worked out each part together. I just want you to tell me the final answer. All right. So if one part is 12 square centimeter here, and we have another part 4 square centimeters, and we have this part 3 square centimeters, let's go ahead and figure this out. So we first have to add all of these. I mean, we can do it different ways, but I'm just going to go ahead. I'm going to add all of these, which will give me 12 plus 4, 16 plus 3, 19 square centimeters. And since we have 2 of each, we will do what to get our final answer? All right, Jenor is so much ahead of us, and Jenor says that we would know. Let me see where Jenor is at that point. All right, and Jenor used a different way to answer her question. So say we're using this. Since we had 2 of each of these, we now need to multiply 19 by 2, and that will give us 2 times 9, 18, 2 times 1, 2, and 1, 3. 38 square centimeters. That would be your final answer. Now, for persons now who did it a different way, meaning that they multiply the 12 centimeters, they multiply the 4 centimeters, square centimeters, they multiply the 3 square centimeters, and then they added all of that. And they still came up with 38 square centimeters. Now, once that is your answer, that is, you are correct, because that is how we will solve this. Now, I'm going to go through this real quick for those who we would have lost along the way, those who didn't understand straight away. So I'm going to explain this. Now, when we're finding total surface area of a solid, it means that we're going to find the area of each individual face. A cuboid, which this figure is, has 6 faces. And so we will find the area of all 6 faces. Now, because it's a cuboid, we don't need to find for all 6, because for this face here at the front, it means that we have 2 of this, because this one at the back that we can't see opposite this one is the same. So we know that we have 12 plus 12 square centimeter, which will cover these 2 faces. At the top, we have the area 4 square centimeter, because we know the length and we know the width, but we also know that this at the top, the base is the same size face. So we can go ahead and we can add that, 4 square centimeter to 4 square centimeter, or we can multiply by 2, and we would have now, accounted for the top and the base faces. What about these at the side? We will go ahead and find the area of all of these, and then we will total all of those measurements. And in this case, we came up with 38 square centimeters. All right, very good, guys. I see some 38 square centimeters coming in. For those who do not understand, I hope you understand with my final explanation here. And if not, you can always go back to the video, pause, go through, look at the calculations until you get your understanding. So the correct answer is 38 square centimeters. Very good. Let's now go to the next one. What is the surface area for this? Now, we have done it for the first one, so I need to see the answer coming in for this one. So what is this solid called? And if you know what the solid is, you will be able to go ahead and find the surface area. So I want to see persons doing their calculations here. When you have done your calculations, then I will go through here with calculations as well. But I want you to try first. All right. All right. Yes. Thank you, Melita Lewis. So this is a cuboid. This is a cuboid. All right. All right, and I see a lot of persons coming in with cuboid. Now I see Tamar saying cube. Now remember now that a cube has all square faces. And while we have two of these faces are square faces, we have rectangular faces too. So this is not a cube, but instead it's a cuboid. A cube has all square faces. That means all the 6 faces in a cube are the same size, like a dice, okay? Like a Rubik's cube, those kind of a thing. But like a cuboid is like a a toothpaste box, that you buy the toothpaste in. That will have the shape most times of a cuboid. So you realize that this has rectangular faces as well. So this is a cuboid. All right. So let me see what you guys are saying here in the chat. All right. So, okay, so I see person saying it's 78 square centimeters. All right, let's go ahead and think about this. So we know that in a cuboid, we have this face is the same size as the one underneath. We have this one is the same size as the one over this says that we can't see. And we have this one is the same size as the one over here that we cannot see. Now, as Michaela has explained for us here, we're going to find the area of each of these faces. So I see where Michaela said that the area for this face at the top is 3 centimeter, because right here is 3 centimeter. That means here is also 3. Here is 3. That means here is also 3. And so for the top face is 3 centimeter multiplied by 3 centimeters. 3 times 3, 9 square centimeters. All right. So we have found for one face. But we know that the one underneath it at the bottom is also 9 square centimeters. So we can go ahead and we can multiply this by 2. Or we can just add it to itself, add it twice. Now let's look at this front face, because Michaela says now that 3 times 5, because we have 3 here, and that means this is also 3, and we have 5 here, that means it's also 5. To find the area of this, it will be 3 times 5 centimeters, which is 15 square centimeters. So I'm going by what Michaela Hamilton is explaining here in the chat. 15 square centimeters. So we know that the area for this face is the same area for the one behind it that we cannot see. Now for this face here, we have 3 centimeters here, and this part is 5 centimeters, because right here is 5 centimeters. So, here is also 5 centimeters. So we're going to multiply the length times the width for this face, which is same 3 centimeters multiplied by 5 centimeters. And as Michaela says, that is 15 square centimeters. We're going to write that here. I hope we're all following, or you would have already done your calculations. Now that we know the area of these faces, we know that for this face is 15 square centimeters, so the one at the back is the same too. So for what Michaela did, because you can do it in different ways, she added all of these 15 centimeters plus 9 centimeters, that is 24 square centimeters, plus 15 square centimeters, that is 39 squared centimeters. And since we have 2 of each of these faces, I'm going to write my 39 square centimeters here. And since we have 2 of each, we now need to multiply this by 2 to see what the surface area is. All right, so 2 times 9. Help me out here, guys. 2 times 9, 18. 8 ones, 110. 2 times 3, 6. plus 1, 7, 7, 10. So that is 78 square centimeters. So our surface area is 78 square centimeters. Or we write it like this. All right. All right, very well, because I see you all coming in with that answer. Very good. Brilliant. All right. Let's move on to our next question. All right, so here is a sample CBT item in regards to surface area, and I want you guys to approach this, try to explore this one, and tell me the answer that you came up with. Now, for this one, you realize that for this rectangular prism, which is the same as a cuboid, they have shown the net of it. So we have the net showing here, because basically surface area, as I would have said before, is if you open up this cuboid, if you open up the toothpaste box, you know, it will become a net. So we'll be able to find the area of it when opened, or we can just, using the principles, we can find it when it's still a rectangular prism or it's a cuboid. All right. All right. Yes, guys, you guys are doing very well. All right, and I'm very proud of you. So let's look at this one now. So we have this rectangular prism, and it says, what is the surface area of the prism? 72 square centimeters, 44 square centimeters, 40 square centimeters, or 36 square centimeters. So I want you guys to do your calculation and tell me how you got it. So go ahead. I'll just wait here for a while. I may be silent while you work. And remember that your answer is not complete without square centimeters on it. All right. Okay. So I see person saying 36 square centimeters so far. I see Michaela showing her workout and saying 72 square centimeters so far. All right. Let me see what the others are saying. Melita says you can just count the little squares in the middle to get the answer. That's also really good, Melita, provided that you got it like this on a grid paper. All right. All right. So I see persons sharing 72 square centimeters. Let us go ahead and do this together to see if it is really so. So I'm going to go ahead and I'm going to find the area of the different faces. And you can see where the way this is drawn, we can practically see the face behind, right? So let me talk about the top face, talk about this side face here, and let me talk about this front face. All right. So what's the area for the top face? Go ahead and tell me the area for the top face. So I want to see in the chart, top face equal, and you put the area. All right, go ahead, share the area for the top face. And if you work really fast, you can also go ahead and find the area for the side face and the area for the front face. You can always put it like that. I also see Lisa Marie McFarlane doing lovely calculations here. So let's do this together. The area for the top face. So remember now, when you're finding area, we're using our formula, length times width. So for the top face here is same as the bottom face. That means right here is 3 centimeters and this is 2 centimeters. So length times width is 3 times 2, and that will give us 6 square centimeters. So I don't want to see any just 6 coming in the chat. That's not an answer. We're asking about area. So we have done that. The bottom face, the base, the top, they're both the same sizes. We're looking at rectangular prism or a cuboid, same thing. So let's look at the side face. The side face would measure what? All right, so I see Danae and Dominique coming in with their top face and the base. Very good. Let's look at the side face now. So we've got this side face as dimensions 6 centimeters for length, 2 centimeters for width. So it means then that this side dimension is what? 6 centimeters times 2 centimeters, which is 12 square centimeters. Thank you, Tamar, and thank you, Melita. 12 square centimeters. Let me go ahead and write that. Let us look at the front face. So for this front face, let's look at the length right here. If this part is 6 centimeters, it means that this is also 6 centimeters. And right here it is showing that this is 3 centimeters. So length times width, 6 centimeters times 3 centimeters. 3 times 6 or 6 times 3, that would be, Tamar Johnson said 18 square centimeters. Very good. 3 6 is 18. 6 times 3, 18 square centimeters. Let us write our units on. Now, since it is that we have 2 of each of these faces, we can go ahead and find the total of these, then we multiply by 2, or we can just multiply each of these by 2 and then add it. I'm just going to do one big calculation of these individual faces, then multiply by 2, because we have 2 of each of these faces. All right, so we have 18 plus 6, that is what? 18 plus 6 is what? All right, that's 24. 24 plus 12, that's 36. So we have 36 square centimeters. But look in our answers. There we're seeing 36 in our answers, you know. But the question is incomplete. So 36 square centimeters cannot be our answer, because we have 2 times each of these faces. So we're going to multiply by 2. Help me to multiply, guys. 2 times 6 is 12. 2 ones, 110. 2 times 3, 6 tens times 1, 7 tens. So we have 72 square centimeters. The surface area is 72 square centimeters. Is that what you got? Did you get 72 square centimeters too? All right. And so the correct answer for this is A. Very good, guys. Brilliant. All right. So let's move on to our next question. And this question, we're looking at the mean, mode, and median. All right, so what is the mean? Give us a sentence in the chat. What is the mean? What is the mode? What is the median? What do these 3 things mean? Because we're looking at statistics now. What does mean mean? What does mode mean? And what does median mean? All right, so I should be seeing some explanations coming in the chat. And let's move on to our first item. All right, so mean has to do with the average. So mean has to do with the average. And some of you would like to put it to say that when we find the sum of a number of values and then we divide by that the amount of values that we found the sum for. So Tat D is saying mean means average, and you are basically right. All right, median, Lisa Marie says median is the middle number. What is it just the middle number? Is it just the middle number? We must do something before we can come up with that middle number, right? All right, so let me see now. So mode, Crystal Life says mode is, often. All right, so that means mode has to do with the frequency of a value, or often it appears. All right, and as Dolores says, the one occurring the most. Very good. And Nia is saying that median is the middle number when we rearrange the numbers. Now, when we rearrange the numbers, we mean in ascending or descending order. That is important to note. Really good, very good, guys. So mean has to do with average. Mode has to do with the frequency. That means the value that appears, the value or the object or the figure or the item that occurs most frequent, while median is the number or value in the middle when we rearrange those values in descending or ascending order. Let's go to our first question. It says Lila is emailing some photographs from her computer. 7 pictures have file sizes of 2 megabytes, 2 megabytes, 1 megabyte, 3 megabyte, 3 megabytes, 2 megabytes, and 1 megabyte. And what is the median file size? Now, since this is pretty, easy for us, I want to see your answer and a sentence telling me how you got your answer. All right. Your answer and just a sentence telling me how did you get your answer. All right. So people are saying 3 megabytes, but I don't know how you got that. All right. So I need to see a sentence telling me how you came up with your answer. Is the answer 1 megabyte, 2 megabytes, 3 megabytes? I don't know. Tell me. All right. So Jay Sean says that he rearranged the number from ascending order and it was 3. So I'm going to arrange it from ascending order. Ascending order means from the smallest to the greatest. So I'm going to have, let me just rearrange them here. So we have 1 megabyte. We have 1 megabyte again. We have 2 megabytes. Okay, so we have 1, 2, 3, 2 megabytes. 2 megabytes again. 2 megabytes. And then we have, let me see, 1, 2, 3 megabytes. Guys, correct me if you see me making an error, okay? So let me see if we have 1, 2, 3, 4, 5, 6, 7 file sizes. Good. So here we have it. Now it says the middle number. So let's see the middle number. Okay, let me just go ahead and keep crossing out from the sides. All right. And so the middle number is 2 megabytes. So did you get 2 megabytes for your answer? Because if you did, you are very much correct. Very good, Dominique Jones. All right. Okay, very good, Elena. Very good, Labrina. Very good, Nicora. You all are on the same wavelength as I am. Nice, brilliant. So we rearrange these from the smallest to the greatest and we look for the number in the middle. All right. Now, sometimes when we have 2 numbers in the middle, well, all the time when we come up with 2 middle numbers, what do? If we had 8 numbers here, what do we do with the middle numbers? If we have 2 medians, what do we do to come up with only 1 median? Can anyone tell me what do we do? If it is that we had 2, because like for 7, we will definitely only have 1 median. But if we add an even number, like 8 or 10 or 6, we would have 2 medians. But how do we arrive at only having 1 median? Go ahead and tell me in the chat. Okay, we add them and then we divide by 2. Very good, Gregory, Catherine, Verna. Thank you so much for that explanation. All right, let's look at this one. Mr. Hoover took his children to an all-you-can-eat pancake breakfast. That sounds like fun. If you like pancakes, you must like this kind of breakfast. The 8 children ate. One ate 6 pancakes, one ate 5 pancakes, 1 2 pancakes, 1 6 pancakes again, 4 pancakes, 1 pancake, 6 pancakes, and 2 pancakes. What is the mean number of pancakes eaten? What is the mean number of pancakes eaten? Before, you guys said that mean is the same as average. So I could say, what's the average number of pancakes eaten? Yes, guys, very good. Okay, go ahead and tell me what we have here. All right. Okay. So while you are working on this, I'm going to work on it as well. And let me see if I can see some explanations in the chat. I see person saying the mean is 4. How did you get that? All right, so Labrina and Lisa Marie added 6 plus 5 plus 2 plus 6 plus 4 plus 1 plus 6 plus 2, then divided the total which they got, which was 32, by 8, and they got 4. Nice. Very good. That's exactly how we will solve a question like this. So we add all the values. We're finding the mean. So we add all the values. 6 plus 5 plus 2 plus 6 plus 4 plus 1 plus 6 plus 2, and you guys said that is equal to 32. So now we know it's 32. We divide 32 by 8 because we added 8 different values. We divide 32 by 8 and we end up with 4. So the mean or the average is 4. 4 pancakes. Brilliant. Very good. All right, let's move on to our next question. A quality assurance engineer is measuring the diameter of some newly manufactured pipes. She measured 6 pipes and noted 6 diameters off. All right. So the diameters that she have noted is 6 centimeters, 4 centimeters, 5 centimeters, 5 centimeters, 4 centimeters, and 4 centimeters. What is the mode of the diameters of the pipe? What's the mode? Why is that the mode? All right. What is the mode and why? All right. Vashon says 4 centimeter. Lisa Marie says 4 centimeters. Jay Sean agrees. Michaela Hamilton is agreeing as well. So is Gaming with Ari. And Jay Sean says it appears the most. Melita says 4 centimeters because it occurs the most. Definitely. We have 1 here 6 times. We have 4, 1, 2, 3 times. And we have 5, 2 times. And so the correct answer has to be 4 centimeters because 4 centimeters occurs the most. Brilliant. Very good. Now, as we are at the end of the session, the last point, the last subtopic, the last concept we're going to look at is the volume of prisms. And I am happy that we're looking at this because I remember that when we started to explore surface area, someone brought up something that belonged in this concept. So let's go ahead and explore the volume. Now, when we talk about volume, we're talking about solid objects, right? The space occupied in a solid object, right? So what is the volume of this object? Real quick, let's look at this one. This is showing you a cuboid. I know you know that because we have been looking at cuboids. So this is showing a cuboid. Can you tell me how many cubic units there are? How many cubic units are there in this one? Now, if you are able to see this physical representation of what volume is, you should be able to answer the other questions that are coming up. Because when you have a solid object, like a toothpaste box, you know, like a phone box, like a box that you probably buy some butter kiss in, the empty box. When you look at that and you want to see what is the volume of it, it's basically like this. You're just not seeing all these, equal, these cubic units in it, but really you are calculating cubic units when you're calculating that. So for this one, I see all of you coming in with 1, 2, 3, 4, 5, 6 cubic units. And you are so correct because we're seeing that. But let's go to the next question. Let's go to this question. What is the volume? Now, in this one, you are seeing the butter kiss box now. You're seeing the box that the tough crackers came in, or the cream crackers came in, or the digestive biscuits came in. I don't know. But you're seeing the box now, and you're not seeing the different cubic units. So let's look at this box. We have the box here. And it is what? What kind of solid is this? Who knows? What is this solid called? And how do you know? Like, I mean, we have not looked at any solid like this before. What is this solid? And how do you know, what the solid is? All right. I see persons coming in. Lisa, Maria, Michaela, Milita. Yes, it is a cube. It's a cube because all the faces have the same sizes. All of the faces are square, of the same, not sizes, but the same lengths. So all the faces are squares. So this is a cube. All right, now we're finding the volume. Now, when we're talking about volume, guys, we talk about volume, we talk about not just length, the dimensions of length and width, but we also talk about the breadth. All right, so we talk about, say, this is the length, this is the width, but because length and width having to do with a two-dimensional thing, this is further, we talk about the breadth as well. All right, so when we're finding volume, we're finding the product of the length times the width times the breadth. All right, or times the height, whatever you want to use, height, breadth, anything, because these dimensions we may name them to be specific, but they're all really lengths, but so we can call it length, the width, the height, the length, the width, the breadth, and so on. Now, if the length is what? If this is 6, that means it's also 6 meters. If the length is 6 meters and the width is also 6 meters, and say the breadth is 6 meters, what would the product be here? 6 multiplied by 6 is what? What is 6 times 6? 6 times 6 is 36. Brilliant. And 36, so 6 times 6 is 36. And 36 times 6 is, 36 times 6 is what? 216. And since we're finding the volume, we're talking about 3 dimensions here. The length, the width, the height, or the length, the width, the breadth. We're talking about the 3 dimensions. We represent it as cubic meters, and we write it like this. All right, so our answer is 216 cubic meters. Brilliant, guys. I must clap you guys for working on this so quickly. Lovely. I'm really happy that you don't need a lot of practice on this. Very good. All right, so for those of you who still do not understand this question, we have talked about it, so you can always go back, you can always pause, do your calculation to come up with your answer. Brilliant. Let's look at this one. Now this is a sample item, a sample CBT item, so I want to see how you will solve this one. So what is the volume of the right rectangular prism below? What's the volume of the rectangular prism below? All right, so this one looks a little tricky. I think I too need my pencil and my thing to solve this thing here. Let me just get my pencil now. I don't think I can work this one out of my brain just like that. So let me just get my pencil, and as you work, I work as well. All right. So let's go ahead and look at this one. And I think this may be the last question, you know. So let's see how we can work out this one. We're finding the volume. All right. So in finding the volume, we are multiplying how many dimensions. And if you look at this solid here, you realize that this solid is a rectangular prism, as it was said, which is also the same as a cuboid. So I want persons to go, oh guys, you guys cannot win me and just be typing in C in the chat. I need to see your answer and I need to see your explanation for this one. All right. All right. All right, so let me see what you guys have said for your answers. Let me make sure I'm doing my calculation. First quarters. Okay. Okay. Okay, so I see persons coming with different answers. Let me see what you guys have explained then. So Crystal says we change them into improper fractions. So we change them into improper fractions. And since you guys have done your calculations and you're putting in your answers, I'm going to go by what we're seeing here. So we change these into improper fractions. So, all right. So we're going to have what? 2, this is length times width times breadth, 2 times 1¼ times 1½ All right, so we change those to improper fractions. So that would be 2 multiplied by what? What's the improper fraction of 1 1/4? Go ahead and tell me what's the improper fraction of 1 1/4. 4 times 1, 4, plus 1, 5. So that's 5/4. right. Multiply by 2. What is 1.5 as an improper fraction? So let's go 2 times 1, 2, plus 1, 3. This is 3 halves. All right, a different color here. Okay, so now we're going to move from here now. So we're going to work out one set and then we work out the other. So we can work out the first one here. We can do it like this, 2 times 5. So let's write this 2 as a fraction. 2 times 5 is 10. And 1 times 4 is 4. This is 10 quarters. 10 fourths multiplied by 3 halves. I hope we're all here because I'm just working this out with you guys. I have no idea what the answer is. But let's go ahead. So now we have right here, and we can do a cross multiplication. So we can say 2 into itself goes 1, and 2 into 10 goes 5. 5 times 3 is 15. Let's see what Labrina has done here. Okay, Dijonais. All right, so let's see. 5 times 3 is 15. 4 times 1 is 4. So we have 15 fourths. And we now need to simplify that to get our final answer. So we have 15 fourths. So what is the final answer? I'm allowing you guys to work from where we are. All right. I see Lisa Marie saying 3 3/4. I see Nicosaya Mitchell saying 3. Oh, I think you're answering for the first one. Okay. All right. Let me see what you guys are saying about this one. This 15 fourths. 15 fourths. 4 into 15 goes 3 times with a remainder of 3. So 3 fourths. Let me see if this answer is actually there. So 15 fourths is equal to 3 3/4 or 3 3/4. All right, let me go check if this answer is there. 3 3/4. Okay, so that looks like our correct answer is C. Let me see those who got this one correct here. All right, and I realize that some persons got this long before we even worked this out. Brilliant, guys. Brilliant. This one is a little tricky one because instead of giving us whole numbers, they gave us fractions, but I surely enjoyed working out this one with fractions. It's a little challenging and I like that. All right, very good. So the volume is 3 3/4 cubic centimeters. Very good. All right, and that's it. We are at the end of our session. So it was great exploring with you guys. And we did this like 2-hour session. It was great exploring. Remember now, if you want to go back through these items, you can always, the video is always available on this same channel. You can go explore it, pause, work them out on your own. Remember to share this video as well with your friends. Let me know if you learned something in the chat. Let me know if you enjoyed the session. I can say that I did enjoy it. So you have a great Saturday and I will see you next week, Saturday. Bye-bye.